Hello everyone, welcome back to another video of Algebra 2. Today's lesson should be very brief. We'll be covering only sequences like explicit formulas, recursive formulas, and all that good stuff. Okay, so first off, we have the explicit formula for a sequence. So an explicit formula is a type of function into which only positive integers can be input. Sometimes the explicit formula notation resembles function notation. So for example, like explicit notation could resemble something like this, which is very similar to a function. An alternative notation is with a subscript, like a to the n equals 2n plus 3. By substituting the values 1, 2, 3, 4 for n, the first 4 terms of the sequence can be determined. So you basically just plug in. Pretty simple. Okay, on the other hand, an infinite sequence is one that has no end. The ellipses at the end indicates that the sequence is infinite. A finite sequence does have a final term. The sequence 5, 7, 9, 11 is a finite sequence, while the sequence 5, 7, 9, 11 is a infinite sequence. So basically, what it's saying is that sequences with like dots like that, it means it's an infinite sequence. On the other hand, if it's just plain and it ends, there's no 3 dots, ellipses, then it's a finite. Okay, so let's try an example. A to the n equals 5 plus 3 n minus 1. What are the first 3 terms of this sequence? So you want to find 1, 2, 3. And so you plug them in. I like to show out the work like this. 1 minus 1, 0, and that's 5. You basically do that until you get all your answers. So it'll be 5, 8, and 11. I didn't show the work, but it should be simple. Okay, moving on, we have recursive formulas for sequences. A recursive formula has 2 parts. There is the base case, where the first value of the sequence are given. Second, there is a recursive definition, where a rule for calculating more terms is described in terms of the previous terms. So, for example, let's say we have a1 equals 5, and a to the n equals 2 plus a n minus 1 for n greater than or equal to 2. So, this is the base case. This is a recursive definition. It's pretty simple. So, to get a1, there is no calculation needed since a1 is given as 5 in the base case. For a2, substitute 2 for n in the recursive part of the definition. So you just plug in 2. Right. Okay. And notice that the value of a1 needs to be known to do the step. So if you want to find a2, then you have to basically a1, 2 plus a1, which is given. And that's how you find a2. Okay, moving on. Let's try some examples since this is really simple and easy to understand. Example 2. Let's say there's a sequence a1 equals 3 and an equals n times a n minus 1. Oops. N minus 1 for n is greater than or equal to 2. So in this case, a1 is 3. That is given. And you want to find the first 3 terms. Or let's do actually, what is the value of a3 for the sequence? So you have to plug in a2 equals a2 equals 2 times a2 minus 1. So it's basically 2 times a1. And plug in 2 times 3, 6. Once again, do it again. But this time, the previous term is a2, which is 6, that you have to plug in. a3 equals 3 times a3 minus 1, which equals 3 times a2 equals 3 times 6, 18. So a3 is 18. That's your answer. Okay. And then moving on, we got arithmetic and geometric sequences. So a sequence like 5, 7, 9, 11 is known as an arithmetic sequence since each term is equal to 2 more than the previous term. The number 2 in this case is noted as a common difference. So you notice that in between terms there's a difference of 2 and the common difference is 2. That's what it's called, the common difference. Okay? On the other hand, a sequence like 5, 10, 20, 40 is known as a geometric sequence since each term is equal to 2 times the previous term. So and the number 2 right here is noted as a common ratio, usually denoted by a variable r. Common ratio, which equals r, or lowercase r. And this is d, common difference d. Okay. Usually the two formulas will be given in my state, at least they give it to us on the regions, but I'll just write it down for your notice. So geometric, arithmetic, geometric, and our Latin formula. an a1 plus n minus 1 d. And an equals a1 r n minus 1, where d is a common difference and r is the common ratio. Okay, so common questions include you finding the formula for yourself. So let us do like 1 or 2 examples of such. Okay, so find the explicit formula for this, for the an term of sequence right here. Since each term is equal to the previous term plus 4, this is an arithmetic sequence. So a1 7, d equals 4, just to organize your work. And so the formula is an 7 plus n minus 1 times 4 from plugging into this. Right? And let's do another one. Looks up you have to find geometric sequence. Or formula, yeah, explicit formula. So since each term is equal to the previous term times 4, this basically means that a1 equals 7 and r equals 4. So the formula would be an equals 7 times 4 n minus 1. And that's simple. Okay, and other questions are come in the form like maybe what is the 50th term of this? Well, that's easy. You just plug in a50, and that's 50. So a50 equals 7 plus 50 minus 1 times 4. I think that is around 203. Yeah. So there are other questions like that. And moving on to, I think, the last unit, we have basically finite arithmetic and geometric series. So a finite series is like a finite sequence, except all the terms are added together. An example of a finite arithmetic series is 5 plus 7 plus 9. Yeah, I'll just write out 5 plus 7 plus 9 plus 11 plus 13 plus 15. An example of a finite geometric series is 5 plus 10 plus 20 plus 40 plus 80 plus 160. Okay, so note that the only difference here is that you add the terms together. and this is called a finite series. So the formula for calculating the sum of a finite geometric series is given in the reference sheet in the regions for my state, but in this case maybe you guys don't have the regions, or maybe I don't know how it works. So the formula basically is Sn minus a on r to the n 1 minus r. Okay, and let's try it out with the one that we wrote up here. Let's sequence right here. Okay, so to use this formula to calculate 5 plus 10 plus 20 plus 40 plus 80 plus 60, 160, substitute 6 for n since there are 6 terms, 5 for a1 and 2 for r. So S6 equals 5 minus 5 times 2 to the 6th, 1 minus 2, and all that, blah, 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 and you add it up to 315. That's easy. Okay, and the formula for calculating the sum of a finite arithmetic series is Sn equals n a1 plus an over 2. Okay, so let's try an example. Let's say we have this series right here, 1 plus 2 plus 3 plus 98 plus 99 plus 100. What is the sum of the first 100 positive integers in the following series? So the solution, you substitute 100 for n, since there are 100 terms. If you just 1, 2, 3, and then 4, 5, 6, and then 98, 99, 100, okay? There's 1 for the first term, so it's a1, and 100 for an. So Sn equals 100, 1 plus 100 over 2, which equals 10,100 over 2, which equals 5,050. That's essentially how you do, how you utilize these formulas for these finite arithmetic and geometric series. Okay, so I think that's all. Let me check. Yeah, okay, yeah, that's it for this video. It's pretty short, it's pretty easy to understand, and probably in the next video we'll be covering a little bit of a longer unit. Yeah, we'll be covering probabilities and all that stuff. Okay, so thank you for watching. Stay safe everyone, wear a mask. Okay, I'll see you in the next video.